All right, so we're going to start using Kiro and Lean to do math proofs for us, and we're going to start with a banger. We're going to start with the Harvard Math PhD qualifying exams. And so these exams are typically undertaken by incoming PhD math students at Harvard. And so these are students who are good enough to get into Harvard and are good enough to finish the PhD program and to get a PhD in math from Harvard. So these are well above your average math students. And these exams, as you can see, are quite hard. They're not something that the average university math student can do, but we're going to ask Kiro to do it. And we're going to ask Kiro to do it in Lean, so that Kiro has to prove all of the results that it obtains in this formal computer language that checks all of the proofs for it, so that we can be sure that the program is not making any mistakes and that every step in the proof is logically correct and has been validated by the software program. So our first step will be to save this file. So I'll go back and I'll save this file. It will save to the downloads folder. And then I'm going to go to the Finder, and I'm going to move this file from the Downloads folder to my project folder. So that will be over here. Once I move it into my project folder, it will show up in my project, and it will be available for use in Kiro. Now, once we have the file open in Kiro, we can try to view it in Kiro. It may not work for you because the IDE doesn't open PDF files by default. If you do want to view the file in Kiro, you have some options. You can simply go and search for a PDF opening extension, or another option is you can simply type in Kiro, can you please add PDF viewing functionality into the Kiro IDE or something like that, and the AI will do it for you. So we can do that if you want. And so here we go. Kiro has installed the PDF viewing extension for us, and now when I click on the PDF file in the IDE, it will show me the file. But that's not our main point. Our main point in this video is to get Kiro to solve the problems for us. And so we can simply ask it, can you please solve the first question on the Qualls Ring 2026 PDF file in this project folder. Please place your solution in a Lean file. Right, and it'll start working. So it's first going to read the PDF. It's going to, perhaps it might need some programs and things like that. It might need your permission to read the file. And you can see its progress. You can see that it's starting to extract the contents of the file, and it's going to look at it. And this may take a while. This is a hard problem, right? It's like Harvard PhD level. So you may have to give it a little bit of time to digest the problem and find out what the problem is about. You can already see that it's in this little thinking text that it's already identified the key elements of the question. It knows that it's a question about the algebras. It knows that it's supposed to look at killing forms, semi-simplicity, nilpotent algebras, and it's going to so it's going to process it, and we'll give it a little bit of time, and we'll come back later and see what it comes up with. All right, so now we're a little bit later along in the process. It's extracted the entire contents of the problem in plain text. It's engaged some of the skills and some of the tools that we've installed. You can see them here if you expand the tool calls over here. So what it's going to do is it's going to look at this file a little bit more. It's going to process it. It says it's a substantial formalization, but I have faith in it that it can solve this problem. We'll see how far it gets. So now it's engaged some of the LSP tools that we installed in the previous video. It's looking for the items that it needs, things like Lie algebras, killing forms, the definitions related to those. and it's going to look for all of those things, and then see what it can build from all of those. So just looking at its progress so far, you can see that it's already determined that it can more or less solve part C, and it's looking for both directions of part B as well. It's finding these in the MathLib library. It makes sense that some of these statements, they're well-known statements, they're already built into MathLib. I think that part D will be the most challenging part because part D asks for an example, and typically examples like this are not built into MathLib, and it will have to do some reasoning to figure out what the correct example is to give to solve that part of the problem. So here, if you look inside its reasoning, you'll see that it's worked through all of the possible cases for a two-dimensional Lie algebra, and it's identified a particular Lie algebra where the bracket of x and y is x and all the other brackets are 0, and it's looking at that as a possible candidate for the example that is needed in part D. And so that is what it's going to go with, and that is the correct answer. So it is good to see that the AI has worked out that is the direction that it needs to go. All right, so we're now at a natural point where the AI has done most of its thought. It's figured out the strategy and the approach that it's going to use for each of the parts, and it's ready to write at least parts of the solution in the file. And so I'm going to click on the accept button over here to let it write the file. And then once it writes the file, we can actually go into the file and check that it's there and that it's working. And yeah, so here it is. We've got the file open here. If you click on some parts in this file, you should be able to see, well, actually what we want to do now is we want to open the status box so that we can see what the status is over here. So now you can see that it started writing the file. It's got part A, which is the definition of the killing form. It's working on part B, which is this statement that a Lie algebra is semi-simple if and only if the killing form is non-degenerate. The proof right now has an error in it. You can see the error marked by the red X over here, and it's probably going to work a little bit to fix that. Part C is already done. This was largely built into MathLib, so you can see the double check mark over here for the part C theorem. So we'll wait for it to work on part B, and then see what it can come up with for part D. Okay, and now we see that it's worked through the problems with part B, and it's finished this proof. We can check the statement of part B just to make sure that everything looks correct. So the statement should be that a Lie algebra is semi-simple if and only if its killing form is non-degenerate. So we see that in the statement of part B, L is a type which is a Lie ring and a Lie algebra. It's also finite dimensional, and the statement is that L is semi-simple as a C algebra if and only if the killing form is non-degenerate. And so that's the statement that we have over here. It looks like the correct statement, and the proof is correct because Lean has verified it, so we can be pretty sure that this is the correct statement and proof corresponding to the part B of this problem on the qualifying exam. Okay, so here's a simple progress report on part D. I don't know if you can see the small text here, but what the AI has done is it's recognized that there is a connection between part B and part D of the problem, that it can use the result that's proved in part B to help it prove in part D that the desired example is not semi-simple. All right, so now we've gotten pretty far. The program has confirmed that all of the pieces of the part D solution work, and now it's going to put them into the file and check that everything is sound. you can see that there are still some errors in this file, as well as some warnings. The errors are denoted by the red X's. The warnings are denoted by the yellow triangle signs. I expect that the program will be able to clean up these errors without too much additional trouble, and then we'll have the proof that we want. Okay, so now it's gotten to the point where it has fixed all of the errors. You'll notice that in the file there are only warnings left. There are only yellow triangles. There are no further red X marks. So now we have the file, and we'll be able to go up and check that all of the proofs that we want are there. So in this case, this is a Lie algebra, a two-dimensional Lie algebra with bracket given by, well, it was x comma y is equal to y. They've written it here as h comma x is equal to x, and it proves all of the various components that it needs. It proves that this Lie algebra is not semi-simple and is not nilpotent, which satisfies the requirements of the problem. If you want a more plain English description of the solution, the comment header block at the top of the file, which is not part of the Lean code, but is just part of the documentation for the file, goes through the machine's reasoning and how it obtained and arrived at all of these conclusions. Okay, and so here we have it. I think that it's finished everything. It's gotten all the proofs of all the items. There are no errors in the file. Everything is documented and clearly explained, and you can see its reasoning over here in the chat box. So yeah, I think it's really cool that we can do something like this. We can give it what is actually a fairly advanced math problem, something that is PhD level, and it will produce a proof in Lean. You don't need to know any Lean. You don't even actually really need to know very much mathematics to do this. It's really nice that the program can handle all of these little tiny details. Normally when you're writing a formal proof by yourself, you have to deal with all of the little technicalities and all of the finer points of using the language and getting all of the details right, or else you'll get an error and your proof won't build. But the AI is very good at working through all of these details for you. It does take a bit of time. This whole thing took on the order of some 30 minutes to complete. So it's something that it does take some time to do, just like a graduate student would take some time to work through a proof like this. But it's very easily accessible, and I think many of you can benefit from learning how to use this tool and how to make use of it. Like all tools, it has its uses. It can be abused, but it can also be very powerful when used properly. All right, so that's my presentation for how to use Kiro to do formally verified proofs in Lean. Catch you in the next video.